A world where organs can be printed on demand. Where the long waitlists for transplants are a thing of the past. Welcome to the era of bioprinting, a groundbreaking fusion of biology, engineering, and technology that's reshaping the future of medicine. At its core, bioprinting is the 3D printing of living tissues. Instead of plastic or metal, printers use cells, carefully layered to create structures that mimic natural tissues. Imagine printing a heart valve, a piece of liver, or even an entire organ customized for a specific patient. The dream of overcoming the global organ shortage is no longer confined to the realm of science fiction. It's happening, and the progress is nothing short of remarkable. In recent years, scientists have successfully printed mini livers that function for short periods in laboratory settings. Researchers have also created bioprinted skin used to help burn victims heal faster, and cartilage tissue designed for reconstructive surgery trials. While full-sized, fully functional organs are still on the horizon, these milestones demonstrate that bioprinting isn't a distant dream, it's a fast-approaching reality. But how exactly does this astonishing process work? It all begins with a blueprint, a digital model of the organ or tissue to be printed. Scientists create this model using imaging techniques like MRI and CT scans. Next comes the heart of bioprinting, bioink. This special ink is made of living cells, often combined with supportive materials like hydrogels to provide structure and nourishment during printing. The printer then layers the bioink with incredible precision, building the structure from the ground up. Some printers even use multiple types of bioinks simultaneously, mimicking the complexity of real human tissue. Once printed, the tissue is carefully nurtured in a bioreactor, where it matures and becomes stronger, more stable, and ready for testing or implantation. Visualizing this process helps demystify it. The bioink flows through fine nozzles, depositing cell layers that fuse and grow, forming living tissue under controlled conditions. A dance of biology and engineering, all choreographed by cutting-edge technology. As promising as bioprinting sounds, it also opens up a world of ethical challenges. Who will have access to bioprinted organs? Will these breakthroughs only be available to the wealthy, deepening existing healthcare inequalities? And what about the potential misuse of this technology? Could it be commercialized irresponsibly or even weaponized? Another major hurdle is organ rejection. Even with organs made from a patient's own cells, complexities in tissue matching and immune responses remain. Scientists are working hard to develop biocompatible materials and techniques that minimize rejection risks, but the journey is ongoing. Ethical frameworks and strong regulatory oversight will be essential to guide the responsible growth of bioprinting. Without them, the very innovations meant to save lives could end up creating new dilemmas. Before we dive into how bioprinting could reach even beyond organ replacement, if you're finding this journey through the future of medicine fascinating, don't forget to like this video and subscribe to the channel. It really helps us bring you more amazing science stories from the frontiers of discovery. Now, let's imagine what happens when we take bioprinting even further. Beyond organs, bioprinting holds the potential to revolutionize wound healing with customized skin grafts, provide new solutions for damaged cartilage, and even fabricate tissues for research that reduce the need for animal testing. Personalized medicine could reach new heights. Imagine printing tissues tailored to an individual's unique genetic makeup for testing new drugs, minimizing side effects and maximizing effectiveness. In the pharmaceutical world, bioprinting could speed up drug discovery by offering realistic tissue models for more accurate testing. Instead of relying on traditional methods that are slow and sometimes unreliable, researchers could test treatments directly on bioprinted tissues, bringing new medications to market faster and more safely. Artificial intelligence and machine learning are also stepping onto the stage. These powerful tools can optimize the bioprinting process, predicting how tissues will behave and adjusting printing parameters in real time to increase accuracy, efficiency, and viability. The ripple effects of bioprinting could transform healthcare in profound ways. Faster recovery times, lower costs, and treatments tailored to each individual could become the norm rather than the exception. Bioprinting could bridge the gap for underserved communities, offering affordable, accessible medical solutions where they are needed most. As research accelerates and technology advances, the future of bioprinting looks bright. What once seemed like a bold vision is fast becoming reality, a future where science and compassion converge to redefine human health and well-being.